Wait.
That's a little too far. That's a little. Well, USC is the little ivy. It's a mini ivy. I don't like from a frat ivy.
Oh, sorry. I'm sorry. I didn't know what you were asking.
It's a little.
It's just like.
Much appreciated. It's a little like and so. No. Everything's kind of expensive. I know, going to convert like and to buy like $1,000. That big
All right, we're gonna finish up with our last section. This is exponentials of other bases. So we've done natural log of we've done natural log derivative. We've done exponential function e to the x. These are other bases. So right now we've done base e, but if we do base 2 or base 3 or base 5, they're all just going to be kind of extensions from the rules that we've already learned. So we're just going to talk about logs of other bases derivatives and also exponentials of other bases. But yeah, it's going to feel like the natural log and e to the u are kind of parent functions, and then or parent derivatives, and then logs of other bases, exponentials of other bases are kind of built off of those parent graphs or parent rules. So we'll get through that today, and we'll start doing some review. And then tomorrow, I'll give you a quiz review packet, and we'll have Thursday, Friday, and Monday to do a review, and then I'll have help sessions Monday morning and Tuesday morning. So I think there's going to be enough in that packet where we're not going to get through every review in class. So I'll save those for the morning review. But we'll have plenty of time to prep for this quiz. All right, page 17. I'm just going to move directly into the derivative rule here. So I'm going to skip the change of base here. So I just want us to recall our natural log rule. We know the derivative of natural log of u is just u prime over u. So this is really clean because this is base e, and base e just has a clean formula to it. But we're now going to talk about the derivative of logs of other bases. So natural log is another way of saying log base e, and this is a shorthand way of writing log base e. But we're going to do log base a of u, and so this will be other bases. So that other base can be any integer value. So it could be base 2, could be base 3, could be base 8. They're all going to follow this general rule, right? And I want to show this to you. I want to compare these to you so that it'll make it easier for your memorization process. Is that if you know your natural log, you know that log base a is also going to have this component to it. But there's going to be a little bit extra because there's going to be a conversion that needs to happen. So basically what's going to happen is this is going to basically convert into base e and then do the derivative. So that conversion is going to look like this. It's going to be 1 over natural log of a. It's just going to be some coefficient that's going to have to live in front of the derivative, but then the rest of it feels the same. It's just u prime over u. Let me just do a quick example before we go to example 3. Let me call this example 1 here. So for instance, if I had y is equal to log base 3 of 4x minus x squared. We know that this is log base 3. This is not natural log, but it's still in the same family. It is still a natural, it's still a log function. So the derivative will feel the same. It'll still be u prime over u, but there's going to be this conversion that needs to happen. Your a value is always going to be the base that we're working on. So this is base 3. So y prime, first off, we can't distribute, so we have to leave this alone. But we're just gonna follow this rule here. What's my a value? 3. So think of that as just a coefficient that has to be in front, 1 over natural log of 3. Once you get past that coefficient, then it's just the same as natural log. It's just u prime over u. Okay, so what's u prime? Yeah, 4 minus 2x. All over. Yeah, 4x minus x squared. There's no need to simplify. So your derivative looks a little messier, but it is just a slight extension from the rule that you already know. Now, we had all these log properties available, right? Power property, product property, quotient property for natural log. All those properties also extend to logs of other bases. So we can also expand for logs of other bases if we see a scenario that that allows for it. So so just like with natural log, we're always going to look for opportunities to expand, especially if we think our u value is messy. Okay, so we're going to initially go through the same expansion steps as natural log, but then when we get to the derivative, we just have a slight adjustment to adapt to our new rule because it's not going to be base e. Let's look at example 3. Find f prime for our function log base 5 of cube root of 2x squared plus 7. Pretend like this is natural log, right? What would you do first? Rewrite it, right? How would you rewrite it?
You do 2x squared plus 7 to the negative 3.
Yeah, 1 over 3. Yeah, that's right. So it'll be 2x squared plus 7 to the 1/3. So think log properties here. What's available to us? What can we do? Yeah, bring the 1/3 down. If it was natural log, we can bring that 1/3 down. If it's log base 5, we can also bring that 1/3 down. But just keep in mind, this is not a derivative process. This is the expansion process to allow for the derivative to be a little bit easier. Can I expand any further? No, good. Okay, so we can't expand any further. Now, if it was like 2x squared times y, if there's a multiplication or division inside here, we can expand, but anytime we have plus or minus, we have to kind of leave alone. We can't expand any further. Okay. All right, let's move into y prime. We have the rule that we're going to use. So y prime is equal to, there's a coefficient that's already part of the expression. So that 1/3 has to be in front. What's log base 5 going to produce?
1 over L.
Okay, 1 over L/5. And now it just feels like your natural log rule.
So it would just be 4x.
4x over, yeah, good. Yeah, I'm not going to worry if you don't clean up. You can leave it like that. You can merge it into one fraction.
Would you like specify if we got it?
Yeah. If I need a specific form, I'll specify so that you know. But typically, this should be okay. All right, next example. This is also a log that is not base e, but there's no base here. So do you know what the hidden base is? Yeah, good. Yeah, so because base 10 and base e are the most common bases used, so we have a shorthand for that. So for base e is ln, for base 10 is just log. So if you want to put a 10 there, just as a reminder, okay, this is base 10. All right, we prefer not to find the derivative at this stage, right? That is a pretty large u value. So what can we do? Quotient property, yep. So Good, bring the 3 down. Technically, we could expand this, but I don't think it's worth the hassle to expand because that is a relatively manageable U value. But if you want to expand, you can. But yeah, we definitely want to bring that 3 down. And then from here, see if you can finish the rest of the problem. Okay, any questions? Yes. Sure, yeah, you can simplify even further. You can make it 3 over x if you wanted to. But this, not much we can do. And careful, these we can't cancel anything out. This has to kind of stay there. All right, next page. Let's look at exponential functions that are not base e. But even though we have we're dealing with exponential functions now that are not base e, there is a lot of similarity with base e's derivative formula. So I think it's nice to just treat these new rules as extensions of the rules that we already know rather than a brand new set of rules. Does anybody still need it before? So top of page 18. Let's recall an old rule, or more not old, but more recent rule that we already know. We know the derivative for e to the u is just e to the u times u prime, right? We know if it's base e, if it's base e raised to a variable expression, we know that the derivative is going to be just the original function that's going to show up times the exponent's derivative. Right? So here's the new rule that we're going to learn. What if it's a to the u? So a to the u will be an exponential function that's not base e, so like 2 to the x, or 5 to the x, or 9 to the x. That represents exponential function that's not base e. There is also a conversion that needs to happen, but now that natural log of a is going to be in the numerator. So it's going to be natural log of a times, and just like how we have the original function show up for e to the u, we're going to have the original function show up for a to the u as well. So the original function times exponent's derivative. So in a sense, it feels a lot like e to the u. E to the u is the original function times exponent's derivative. A to the u is also original function times exponent's derivative, but then there's a conversion, and it's going to be natural log of a. So we know that it's going to be in this family of derivatives if you have a constant raised to a variable, right? A constant raised to a variable indicates it's this exponential function that fits into one of these rules. So example 5, find f prime for f of x equals 5 to the x squared minus 2x. We need to recognize, okay, this is an exponential function, and this fits into the a to the u rule. Because base 5 falls under that family of base a. So f prime is equal to, what do we start off with? What's first in our derivative rule? Yeah, ln of 5, yeah. And then times the original function, exactly as you see it, times, yeah, I'll put that instead of parentheses as a reminder that stays together. It's messy, but you don't have to do any cleanup. As long as you have all your pieces involved, then that's enough for your derivative. Any questions here? Example 6, find f prime for our function x times 4 to the negative x. We see there's definitely a need for exponential function base a with that 4 to the negative x, but there's also x in front. There's something else that we have to make sure we include. What process is also involved here? X times 4 to the negative x. What do we need to product rule? Yeah, we got to do a whole product rule process there. F prime g plus fg prime. Because we have two distinct variable expressions being multiplied together. We can't just do power rule and exponential and be done with it. The multiplication is causing us to have to go through product rule. All right, f prime. G function, no changes. Back to f. All right, what's the derivative of 4 to negative x?
4 to the negative.
Mm-hmm. Just follow the, let's see. So what do we start off with? Ln of 4 times the original function times negative 1. Yeah, I would prefer that we can resolve our negative exponents a little bit. So let's just get those exponents back down. Just going to separate my numerator denominator, and that's good enough. Yeah.
You explained you got G prime.
Yeah, so G prime, we're following the rule for a to the u, and a to the u is natural log of a times a to the u times G prime. So my a value is 4, so natural log of 4 times the original function 4 to negative x times the exponent's derivative. Negative x becomes negative 1. Yeah. All right, we're gonna just practice with our new rules on the next page, but I just want to list all these rules just for comparison here. So I want to show something here. So the previous page, we know that u prime over u is natural log. That's the review, and then we know that log base a of u is a lot like u prime over u, but there's a conversion that has to happen. So what I want to show you is that I think we understand that a to the u and log base a are both producing natural log of a. that needs to be part of my derivative before I jump into the rules that are more familiar. But sometimes I think we get thrown off as to, wait, where's that natural log of A? Is it in the numerator or in the denominator? And so the way I remember it is, if I see a denominator presence in the rest of my derivative, that helps me remind myself, oh, that natural log of A is going to be in the denominator. But for a to the u, my e to the u and a to the u, there's no denominator presence at all. So that helps remind me that natural log of A is going to be in the numerator. So if I see a u prime over u, if I see something that is showing up in the denominator, and I know there's a natural log of A, that's going to be a natural log of A in the denominator. Page 19. Let's practice a combination of these rules there. And let's go down the evens column here. Okay, try number 40. So this falls under the category of exponential function base 6. This is a to the u, natural log of A times the original function a to the u times u prime. All right, 42. What's needed? Product rule. Yeah. X becomes 1, 6 to the negative 2x stays. F is still x. G prime, my a to the u. I got to do a little bit of conversion at the beginning. So natural log of A times the original function a to the u times u prime. And I'm just resolving my negative exponents, pushing them back down to the denominator. All right, next up, 48, log base 3. We want to use that log base a of u rule. We always want to ask ourselves, is this expandable? we can't expand. There is no messy exponent that we can bring down, and we can't distribute the log base 3 through. So we should be able to go directly into our derivative rule. Okay, these next few problems, our log expression is looking more complicated. So we want to take advantage of expansion, right? What can we do with 50 before we do our derivative rule? Bring that 3 down, right? Be a lot cleaner if that that exponent can come down. So now it's a lot easier to do your derivative step. $52, same process. Get that exponent to show up, expand, and then do your derivative rule. Okay. Any questions up to 52? If you look at 56 here, it's a lot more involvement. We definitely see potential for quotient and product property. I just want to show you something here. If I have a log or natural log of multiple pieces in the numerator and denominator, we can do a quick expansion just by where they're located. If something is part of the numerator, will be expanded out to be a positive natural log or positive log. Anything in the denominator, if we want to expand it, it's basically going to end up with a minus log or minus natural log. So for instance, if I had natural log of A over BC, it'll be natural log of A minus natural log of B minus natural log of C. So I just want to show that we can kind of see that setup here as well. You got that numerator, and then you have the denominator as 2 terms. It's just basically log of 4 minus log of x squared minus log of root 1 minus x. So that way we can just jump directly into our expansion and not have to worry about doing multiple steps of quotient and product property. If something is in the numerator, it'll be part of a positive log or natural log. If things are in the denominator, it'll be part of a negative log or natural log. So I can do a quick expansion and just separate all the pieces in one step. And then I've immediately converted this into 3 smaller problems, and then each would just be its own individual thing. Next up, I'm going to do some cleanup before I explore my derivative rules. I'm going to do one more step of expansion. I'm going to clean up that last term, but everything else is ready to go. Okay, everything is expanded. What do you think the derivative of this would be? Okay, y. This is the constant, right? There's no variables here. This is just some number. We know a number is just going to go away to 0. Right. The rest we can apply our 1 over natural log of a u prime over u rule. Page 21. I'll give you a full review packet tomorrow, but this is just a partial review. Just more logs and natural logs and exponentials. So basically these 4 rules, circling around these 4 rules. So page 21, always consider expansion first. And then once you've expanded all the way or as much as you can go, then you can consider your derivative rule. So okay, page 21, try number 1. And you can check your progress on the key next page, page 22.
Simplify this.
You don't have to simplify. Yeah, you can leave your answer that one step before my final answer, that's fine. Oh, by the way, you guys will stay with me today during advisement. There's fire drill and shelter drill, so just easier to just stay here. No, it should be 8x cubed.
Okay.
Okay. Thank you.
Um, on the test.
Yeah, you can leave your answer simplified. Yeah. You guys get 8x cubed for the numerator.
Yeah.
Okay, sorry about that. I can leave your answer unsimplified.
Where you brought down the front or doing the close property. Does that mean that when we do close the property, that food that you brought down is gonna be in both
Has
lots?
to be distributed right. Yeah. All right, any questions with 1 or 2? Okay, take a look at number 3. X times e to the 2 minus x squared. What's involved here? Product rule, yeah. So we got to go through f prime g plus f g prime. And then within product rule, then you can handle each of the derivatives when they call for it. The unsimplified version is fine as well.
What else?
Yeah, fire drill. All right, any questions? 1, 2, or 3? All right, number 4, what would you do first? Oh, yeah, property, yeah. Let's get that messy U value split up into multiple log terms, and our derivative will be a lot more manageable after that. Number 5, we definitely have to involve log base 10. We have to involve base 8, exponential function base 8, but there's something else. What else? There's no way around it. We have to use what? For number 5. 2 different functions are being multiplied. Product rule. Yeah, we got to do our whole f prime g plus f g prime. But before we do that, we can do a little bit of expansion, right? What's a small expansion step that we can? Yeah, move that exponent 3 down for the log expression, and that way both terms will be ready for your when you are ready to call their derivative rules for product rule. Okay, so your derivative will be very long and sprawled out, but you don't have to clean anything up. Now for your G portion here, you can either have that 3 up as an exponent or brought down as a coefficient. Doesn't really matter.
Is there an example of like that on the quiz where it's like you have to use the energy?
Yeah, you can expect particle. Yeah, tomorrow when I give you the review packet, you're going to see, all the problems laid out, and you can get a much better feel as to what your quiz will feel like. But this is a partial example of quiz problems, but there's some things that we haven't that we need to still review, like log differentiation and derivative inverse at a point. But we've gone through half the topics though for. Yeah, you can bring that. You can have that 3 in front or up in the exponent. Either place is fine.
Certainly. For advisor, I'm so good to go to where my.
That's fine.
You mind if I go back? Yeah.
You can go. You don't go now. But just know that there's going to be fire drill. But yeah, that's fine. You can go ahead.